Let us start characteristic of embedded system. So embedded system is a few characteristics. So first one is application and domain specific. Second one is reactive and real time, operates in harsh environments, distributed, small size and weight, power concerns. So in detail we will study all these points. Application and domain specific. Embedded system is having certain functions to perform. They are developed in such a manner to do the intended functions only. Like if you consider a camera is used only for capturing the picture. So, or else if you consider a copier machine, we call as Xerox machine, this is used just to take a copy of a document. So that copier machine is not used for any other purpose. So the characteristic of embedded system is having some few or only specific applications. All embedded system is common characteristic is it is intended to do some specific functions only. They cannot be used for any other purpose. It is the major criterion which distinguishes an embedded system from general purpose system. So here there is a term called as general purpose system. So computer is one example for a general purpose systems. So computer is used for several purposes. It is used for banking purpose. It is used in offices. It is used for lab. It is used in lab. It is used for engineering purpose to design a new system or to simulate circuits. So it is used for n number of purposes. So there is no one unique specific functions for computer which is used for all the purposes. But our embedded system is not like computers. It is used for only for some particular reasons or some particular functions. For an example, electronics control units of a car or automobile. Its function is to control the few functionalities of the engine. The electronics control unit of an automobile cannot be used for any other purpose. So that's the reason embedded system is having certain functions to perform. For an example, you cannot replace embedded control unit of your microwave oven with your air conditioner embedded control unit. Microwave oven is a one embedded system and air conditioner control unit is another embedded system. So we cannot replace the control unit of a microwave oven with our air conditioner because the embedded control units of microwave oven and air conditioner are specifically designed to perform certain specific tasks. Also, you cannot replace an embedded control unit developed for a particular domain, say telecom, with another control unit designed to serve another domain like consumer electronics. Yeah, in lost all the consumer electronics like TV, each one is having several embedded units. So all those units are specific to that particular devices. So you cannot replace embedded control unit developed for a particular domain, say telecom, maybe a router, which router is a one embedded systems. So there are several units it consists in router. Those units cannot be used in any other system like consumer electronics. This is very important, reactive and real time. Reactive in the sense embedded systems are in constant interaction with the real world through sensors. Yeah, usually we read through sensors are connected to ports of a microprocessor or microcontrollers. So embedded systems are in constant interaction with the real world through senses and user-defined input devices which are connected to input port of the systems. For an example, in an ATM machines, as soon as you insert a card, it should read from the card. So, and as and when you give several instructions, it should respond to that within a definite time interval. Otherwise, we feel some difficulties. Okay. Any changes happening in the real world are captured by the sensor or input devices in real time. For an example, if there is a fire sensor, as soon as a fire occurs, that sensor should sense that occurrence of the fire and it should respond quickly to reduce the damages to the system. So all the embedded system most of the embedded system should be reactive, and it should be real time. Real time means okay. The control algorithm running inside the unit reacts in a designed manner to bring the controlled output variable. The control algorithm running inside the unit reacts in designed manner to bring the controlled output variable. For an example, you are maintaining the temperature of a room to 28 degrees centigrades. As soon as the temperature increases, so some cooling arrangements we should increase, and we should maintain a temperature at 28 degrees. So if it is an engine control unit, as soon as we change the speed or torque of the as soon as you want to change the speed or torque of the automobile should respond to that input, and it should change the torque or speed of a vehicle as per the driver requirement. So if control algorithm, it is a software which is running inside that machine, should react in a designed manner. Yeah, it is designed by a designer. It is designed to bring the controlled output. Which is a controlled output? For an example, in air conditioner, temperature may be the control output. In a vehicle, it may be a torque, or it may be a speed. These are all the controlled outputs. The event may be periodic one or unpredicted one. Sometimes several events may happen. So event, in the sense, the changes in the temperature, this is one event in case of air conditioner units. So inserting the card, this is one event. It occurs in ATM machines, and we will press some keys, and that is also another event. And if it is a speed control of a motor, the variation in the load is one event. The variation in the input power is another event. These are all the events. To these events, our system should respond, so that in spite of the variation in the surroundings, we are expecting some required outputs. If the event is an unpredicted one, then such a system should be designed in such a way that it should be scheduled to capture the events without missing them. That's the reasons most of the embedded systems are connected with several sensors. It may be a temperature sensor or any other sensor. For an example, if it is a temperature sensor, how soon that system should read the temperature, that is designed by our softwares. So sometimes if the same system is connected to a fire sensor, so fire sensor should, as soon as fire occurs, our system should read it. Otherwise disaster will occur. That's the reasons. So we should design a system such that it should regularly read the sensors. Okay, it may be a short circuit sensor, or in a nuclear reactor systems, it may be a temperature sensor, where and all very crucial jobs it has to purpose. Then embedded systems should produce changes in the output in response to changes in the input. So they are generally referred to as a reactive system. That's the reason the air conditioner unit is a very simple systems where the changes in the temperature should be monitored by the system, and using a temperature sensor, and the room temperature should be controlled by changing the inputs to air cooler or heating systems. Reactive and real time. So this is the continued. Real-time system operation means the timing behavior of the system should be deterministic. So listen here. So real-time operation means timing behavior of the system should be deterministic, because for an example, if you consider an ATM systems, so as soon as we insert our card, we expect the message should pop up in the screen, or it should ask for password. Such message should pop up within some determined time. Otherwise, the system will not work. And as soon as we give a password, it should ask, okay, what service you expect, or from which account you want to withdraw money. All these messages should pop up as soon as we give some specific inputs. So that's the reason it should be real time. So if all these messages comes after 2-3 minutes and all, so we say that system is not working properly, so user is not feeling happy. So in the same sense, if the temperature of the air conditioner room changes, as soon as the temperature changes, the system should find out the differences in the temperature, and it should do certain arrangements to maintain the temperature at 28 degrees like required degrees. Or else, if you consider smoke detector or fire detector, that system should read that occurrence of the fire, and it should do some necessary action to reduce the damages as soon as fire occurs. Okay. Deterministic, meaning system should respond to request or task in a known amount of time. ATM designer maybe is knowing that, okay, how much time it takes to ask the password as soon as we insert a card. It may be some like a few seconds, 15 or 30 seconds or something. It should not go beyond that. Then real-time system should not miss any deadlines for tasks or operations. So if the deadline is missed, sometimes it will cause a disaster also. Sometimes it is not okay, because as soon as we apply a brake in our automobile, the entire vehicle should stop. Otherwise, accident may happen. In a missile control system, as soon as we press a button, that missile should hit the enemy aircraft. Otherwise, there is no use of such missiles. It is not necessary that all embedded systems should be real time. These embedded systems nowadays all are not in real time, because some systems may take more amount of time also. It will not cause much harm, like if a printer, sometimes it will not print it within some determined time, even though it is not causing much harm. Okay. Then embedded applications or systems which are mission critical. Embedded applications or systems are mission critical, means very critical applications. There are some examples are flight control systems, anti-lock brake systems are examples of real time. ABS, these are all it's here time is very important. So System should give the output, or it should change the controlled output within some limited time.